Hello friends. So in the last video we saw what is the meaning of set. So as we are studying set theory, we need to know how can we describe certain sets. So today we are going to see in this video how do we describe sets. How are we supposed to describe a given set? So the most simplest way is to just list out all the members that belong to that set. For example, this is a set. It has the numbers 1 to 10 inside it. So this is a simple way of writing it. It becomes a bit more complicated if it has many more numbers. For example, if it has 100 numbers, if it has 1000 numbers. So you can imagine that it will be much more tiring to write all of them down. So in that case, we have to go for another kind of notation. So we will see that notation in a little while. And then we have another example also. So here we have the numbers 2, 4, 8, 16 and 32. This is another set. So both of these sets have been written with all the members inside as they are. Now imagine that the number of elements in the set are very high. Then as I said, it will be difficult to write. So then we have to go for another approach, how we can describe that set so that it's not too long or it's not too tiring to write all the members out, and it should be easily understandable. So as we saw the definition, a set is always a well-defined collection. So if it is a set, then it will have a definition. Sometimes the definition is very clear. So for you, this definition might be very clear. You can see that it has 10 elements in it and it starts from 1 and ends at 10. So simply we can say this is the set of natural numbers to 10. So then this set is simple to write. In the same way, if you have this set, a pattern is clearly visible. You have 2 and then you have 4, which is the second power of 2. Then you have 8, which is the third power of 2, and so on. So these are all powers of 2. So these two sets can easily be converted into something much more simpler to write. So this notation which I have written, where I am listing out each of the elements, this is known as the roster form of notation or tabular form. We are mentioning each and every element. The other way of writing is the set builder form. So we are going to describe a set based on its definition. So let us try to convert this into a set builder form. So very clear, we can just write this as that's it. So what it means is this set contains all elements x such that the x is a member of natural numbers. So we saw what is this symbol. It means it's a member of natural numbers, and x is also less than or equal to 10. So for this set, it was easy to convert it into this. Imagine if this set had 50 elements, 1 to 50, then we simply change it to 50. So we can easily write this particular set in a set builder form. In the same way, let's try to convert this particular set. It's very simple again. That's it. So all it says is this set contains all elements in the form 2 to the power of n such that, so this is such that, you can also write it as a colon. So in some of the textbooks, in some of the texts, this is the notation used. So you don't have to get confused. You can use any of this. Such that n is the member of natural numbers. So it only takes the values 1, 2, 3 and so on. And also it is from 1 to 5, both included. So you can see 2 to the power 1 is 2. Then 2 to the power 2 will be 4. 3, 8. 2 to the power 4 is 16 and 2 to the power 5 is 32. So simply I have written the powers of n till 32 in a simple form. So like that we can try to convert many more sets into this form. Let us see some more examples. So now we are having these two examples. Let us try to convert them into a set builder form. So this particular set has even numbers and it is in a range. It starts from -6 and it ends at 6. So we have some hint. So it has even numbers. So what is even number generally denoted as? It's a multiple of 2. So we have some hint now. So let's start doing it. So this particular set contains even numbers. So we can say, suppose that number is x. All the x's are even. So we can say that x is equal to 2n, where n is an integer. So this time we say that n is an integer because it also has negative numbers. All of them are even numbers. So n belongs to the integers because there are negative numbers involved, and also the value of n must not exceed 3 and must not be less than -3. Only then we can get these elements. So let's write them down. That's it. So the set contains all x's such that x is equal to 2n, so the form of an even number, where the number n is an integer lying from -3 to 3. Only then we can form this set. For example, if this set had few more elements, say -8 and 8 on that side, or even just an 8 on that side, then we just have to change these values. This remains -3 and this will become 4. So like that we can always somehow find the property of the given set. Now let's consider this particular set. So you can see a pattern already. The numerator and the denominator have a difference of 1. So if this is 1, this is 2, then 2 and 3, 3 and 4. So all the elements have the numerator and denominator difference 1. So then we can simply write this set as always the denominator is 1 larger than the numerator. That is what I can say. So if the numerator is 1, the denominator is 2. So the value of n starts at 2 and it finishes at 8. So we only need to consider n. So we can say that n belongs to the natural numbers. That is very important. And n starts from 1 and finishes at 2. Sorry, at 8. So now you can, if you start substituting the values of n, you get 1 by 2, and then you take 2, you get 2 by 3, and so on up to 8 by 9. So all these elements are covered. So even if there were more, you just have to change these bounds and you will get your set. So in that way, we can try to convert all the lengthy sets into some sort of structured manner. This should be true for all sets because set is well defined. Well defined means it has a definition. So we should be able to get a form like this if it is a set. We'll see the properties and some other types of set in the next video.